I'm Eliza Wood, and I'm a director here at Riveron Consulting. In this role, I was the project manager of HMI Glass, helping implement both a lean implementation project as well as combining that with the intelligent manufacturing solution.
I'm Remus Pop. I am the technical director of our Intelligent Manufacturing Solutions group here at Riveron. I specialize in digital factory, Industry 4.0, and the industrial Internet of Things. My role in this project was to act as a technical lead, instructing our development team on how to build the application.
I'm James Burnett. I'm the CEO here at 4IR Solutions. 4IR is the leading provider of cloud and hybrid cloud-based solutions for manufacturing, and we're an inductive automation solution partner.
Riveron's Intelligent Manufacturing Solutions team defines and implements a digital manufacturing strategy that promotes operational excellence using connected intelligent equipment and real-time manufacturing data. Using these advanced analytics, our approach empowers manufacturing executives to make rapid plant-level decisions and drives overall enterprise value.
For this project, we worked with Riveron and the HMI Glass team to develop a scalable architecture that would allow for efficient and secure deployment of the Riveron application. In addition, we worked with the HMI IT team to securely connect their ERP data to the cloud for reporting purposes. This was all accomplished using our flagship platform as a service, Factory Stack.
So HMI Glass is a $150 million annual revenue company that's private equity owned and makes glass shower doors. They're headquartered in Louisville, Kentucky, with two other main manufacturing facilities, one in Reno and the other one in Boston, as well as 5 distribution centers. The company is a full-service supplier of shower enclosures and architectural aluminum, and it manufactures and distributes those glass and metal products throughout the United States. The problems that they were facing really involved numerous challenges impacting profitability. So the scope of this project was to utilize intelligent manufacturing data to help implement a lean management model and drive that cultural transformation, combining both the people process side with lean and then the technology coming in from the intelligent manufacturing side. The success of this project was unique in that it was tied to fees based on performance, and we utilized a gain share model based on a cost of poor quality improvement, specifically trying to reduce scrap within the facility and also increase throughput.
So Ignition played the role of both combining ERP data via connections to a database, as well as working with Opto22 to deploy some IIoT hardware in the factory because we did not have access to machine controller data. So in this environment, a lot of the equipment was legacy equipment, and we had to get creative with the ways that we were able to pool utilization data for the purposes of showing things like OEE and utilization off of a machine. So using Ignition, we were able to visualize where product was in the work order process and able to visualize that to an operator that allowed them to more efficiently troubleshoot where things were getting lost in their facility.
So here at 4IR Solutions, we have our platform as a service Factory Stack that we use to enable an Ignition in the cloud. We're hosting a version of Ignition that runs inside of the cloud, has its own database, and has its own services that are associated. These services, things like DevOps for source code control, integrated authentication with Microsoft Azure AD, automated backups, automated software updates. One of the benefits in this project is that it meant that the IT team for HMI Glass had to do no work for them to have a system that was fully functional and fully managed available for this application. You'll notice that there's a couple of different lines that are connected. The green line is how the data is being extracted. So Opto22 units with Opto Groove Rio units for I/O were connected up inside of the factory, and then using MQTT over SSL, they were connected up to the cloud to be able to produce the information that was needed from the equipment. The purple line where it says SSL inside of dedicated VPN SQL replication, what we did there was we set up a dedicated connection from each one of the ERP systems. In this case, it's just the facility on the left, to be able to pull the data out of the ERP system so that it could be used for reporting without affecting the performance of the system that's operating on the plant floor. The system that was operating on the plant floor was in a fairly challenged state in that there wasn't a lot of bandwidth available on the computer. There was some memory constraints, so there was some work that had to be done to ensure that the system that was operating was stable, but that we had access to the full catalog of information that was available inside of it from our cloud application. So using replication wrapped inside of a VPN, we were able to accomplish that by pulling that information into an Azure SQL database located in the cloud. This architecture is highly flexible and scalable. So we do show a future manufacturing site on the right. This architecture can be scaled out to dozens of manufacturing sites should the need ever arise, and will allow for HMI Glass to be able to add other functions and features in the future.
We really took advantage of Opto 22 and the MQTT ability of extracting that data from within a factory while keeping a facility in full production. We used the Groove Rios attached to some vibration sensors and some additional sensoring to be able to bolt on or augment an existing piece of equipment with some Industry 4.0 or IIoT capability. So without being able to access the machine data directly, we were able to take advantage of modern era hardware in combination with some modern era transmission protocols to take advantage of a solution that we could put in place rapidly while understanding that the capability needs to exist within a factory to not affect production. So as we mentioned with the project, we use Ignition to connect to an ERP database to allow operators to view work orders through the process in the factory. So you can see here as how we used Ignition to pull in data from a database that was replicated in Azure. And we were able to pull that through looking at things like shipping route, route name, our target ship date, the amount of orders within that work order, and then the percentage complete. So you can see here we have a wide variety of different orders through the facility process. And what we're going to do is we'll click through on one of these and you'll be able to see the detail of where that order is in process. So I'm going to click through on this one here. It's about 42% of the way through production. When we can see very clearly that within that work order, we've completed the first 2 work order steps. We're in the 3rd step with the remaining 2 to be completed. This is dynamically created based off of the parameters within that work order. So if there are additional steps in that work order, more will show up here, and the window will adjust accordingly based off of the amount of work steps in that work order. And then again, green and blue to determine where it is in process. Another screen is being able to take advantage of the Opto 22 resources to be able to see whether a machine is running, faulted, or in standby. So based off of the processes we have within the facility, pulled from the ERP data and additional steps within a factory, we can use our Opto 22 Groove Rios to determine whether a machine is in a running state, a standby state, or a faulted state. So again, taking advantage of that legacy hardware and not being able to access the machine directly, we were able to still gather some intelligent information from a machine without accessing the controller directly. On top of that, you'll see it flips through and when status changes, we can determine a basic level of information to see how our manufacturing process is running. Next, we'll click through an and-on screen, and this is intended to show our hour-over-hour production within a facility. So we have 3 shifts in this factory, shift 1, shift 2, and shift 3. And in each shift, we have an hour that we are producing product. And at the bottom of that square, you'll see our target. You'll see the actual as the big number, and then red, yellow, green, whether that we were close to the target, not even close to the target, or we reached our target production for that hour. So this is basically just a way to understand and put on a big screen within a factory. We can look at very quickly to see how is production running? Are we close to target? Are we off of target? We can see our performance numbers, our deltas to actual, and get a pretty good insight of what's happening in our facility. Next, we'll click through an additional screen to look at a reporting mechanism of combining all those different sources of data to understand more of an OEE type dashboard. So here you'll see our aggregate information of data in the top left, our hour-over-hour production, our actual production versus our target, our quality, availability, and performance numbers, which we use the Opto 22 hardware to get to. We pull in some characteristics like MTTR and MTBF. So if you're familiar with those, it's a mean time to repair, which is on average from when a machine goes down, how long does it take to come back up? Mean time between failures, which means on average, how long does a machine run before it fails again? And then just pulling in our aggregate downtime fault. So we can look very quickly to see, we've had a crash, we've lost 2,000 seconds of production, and that happened on August 14th at 1 p.m. So this is just the ability to, again, take all that data that we're pulling from multiple different systems and using Ignition, create an intuitive dashboard that allows operators and supervisors to understand what's happening in a facility on a shift-by-shift basis.
We were able to provide HMI Glass with a true north metric for reporting to executives and operators, incorporating those metrics into huddle boards, reporting, and performance reviews. By using the route optimization and lean management principles, HMI Glass improved on-time delivery from January to June from 21% to 69%. It also improved revenue by 37.5% and reduced cost of poor quality by 9%. HMI Glass now has visual reporting on the floor and visual management for operators and plant management. Because of the improvement of HMI Glass's operating metrics and the performance-based business model of the project, Riveron has received a significant gain share fees, resulting in a win for both the customer and the implementation partner. As we look to the latter half of the year, We will be deploying this technology as well as the lean management systems to both their Reno facility and Boston facility, building upon the great success that we've had within their headquarters in Louisville.